Welcome everybody to our webinar about our polyester dyeing technology, HeiQ Clean Tech. My name is Roelke Giromero. I am Digital Marketing Manager at HeiQ, and I will be guiding you through our webinar today. We'll have 30 minutes of presentations, followed by 15 minutes of questions and answers. You'll be able to ask questions throughout the presentations by using the Q&A button. Do not use the chat, use the Q&A button to ask questions. Now, to introduce our three speakers, everybody please come up to the screen. First up, we have Paul Middleton. He's our Global Technical Director at HeiQ. With 38 years of experience in the industry, he's a well of information and will be able to answer any questions that you are asking him at the end of the presentations. Paul has a degree in dye and polymer chemistry, and he's very experienced in wet processing and guiding R&D projects into bulk processing. Then next up, we have Gregory, our Chief Sales Officer, North America at HeiQ. She holds a bachelor degree in chemistry and biology, and with 30 years of experience in the textile industry, she's very experienced. She primarily gained these experiences in R&D, chemical manufacturing, technical service and sales in North and Central America. Now, our third speaker is Keith Zimmerman. He holds a bachelor degree in textile chemistry, in dyeing and finishing. He had 34 years of experience in the textile industry, and before joining HeiQ as Director of Textile and R&D, he worked for such prestigious companies as Hanes or Cotton Incorporated. Together, our three speakers have more than 100 years of experience in the industry. Right, now I will stop this introduction. Let's get to it. Jen will start the presentation.
Okay, HeiQ was born on a hike in Switzerland in 2005 by two friends. The focus of HeiQ was to promote hygiene, comfort, and protection to the consumer. Next slide, please. As you can see, we're a leader in R&D innovations in many industries and are partners with 300+ brands. Sustainable innovations is one of our primary focus areas, and HeiQ Clean Tech is one of our primary platforms for this year. Hope you can also see that we have several awards for innovation, which we are very, very proud of, and we have partners in many, many different industries. Next slide, please, Paul. As you can see, we have a lot of sustainable product groups. We have Symbio, Clean Tech, the water repellent, which is PFC free, fresh air, fresh products, and we also have a lot of other sustainable products that are in the works right now. Clean Tech, as I said, is one of our primary focus groups, which I hope you will be able to see in the following presentation. Now I'll hand you off to Keith.
Keith, you're muted.
Good morning, everyone, or good afternoon. What is the issue that we're facing right now? Next slide, please. Water pollution through the textile industry. As you may or may not know, the textile industry is the largest industrial water consumer and also the biggest polluter in the world. We consume 132 billion gallons of water annually, and just to relate that to some other bodies of water, that's 40 times the volume of Lake Norman, which is a recreational lake here in North Carolina. It's about a quarter of the volume of Lake Tota in Colombia, and it's about an eighth of the volume of Lake Chickamauga near Chattanooga. Next slide, please. So polyester is the most produced textile worldwide. Close to 55% of the world textile production. 111 million tons. Next slide. So due to the crazy inflation that we're facing around the world right now related to the war in Russia or war in Ukraine and other places, inflation's on the rise. In Europe, it's 7.5%. In the emerging markets and developing world, it's about 8.7%. And in Latin America, it's 14.5%. So the textile and clothing industry are facing an unprecedented situation, and many companies are considering shutting down just because of energy costs. So next slide, please. Now, Paul is going to go into the solution from HeiQ.
Hi, everybody. So what solution do we have? It's called Clean Tech. So HeiQ Clean Tech, sustainable polyester dyeing. And 2 years ago, we won a nice award because of its excellent properties. So Clean Tech, sustainable dyeing, polyester dyeing, innovative technology designed to lead and deliver sustainable, economical, and ecological discontinuous piece dye yarn dye for dyeing polyester with dispersed dye stuffs. We're talking solely dispersed dye stuffs, no other method of dyeing polyester. The aims of this system is to reduce the dyeing time and the energy use. So we can see a 35% reduced dyeing time, down from a typical 3 hours to 2 hours, more than 30% in saving in energy and water, 30% lower CO2 emissions during the dyeing process. Overall, 30% less dyeing costs. You can increase reproducibility because you're controlling how much dye is going on to each dyeing, so you get better first time dyeing and dyeing from batch to batch. You start getting perfect level colorness and from start to the end of the actual dyeing, if it's yarn or if it's actually on the jet, and it improves the fastness properties as well, which we'll go into. Right, as I've already said, we've won several awards in Switzerland because of this system. It can be easily integrated into the current dyeing system. One thing, you don't have to adjust your dye stuff recipes. It is simply you are taking out your current leveling dispersing systems and you're putting in the Clean Tech system. It can be used on wovens and knits and yarns, and it can be used across a wide range of different dye machines, yarn, jet, fabric, and even loose stock dyeing. It's Bluesign approved, it's ZDHC approved, compliant, and OCTEC. It has no impact on your wastewater, on your effluent system. The actual chemicals are called HeiQ DyeFast PES DIS, HeiQ DyeFast PES LEV, and DyeFast PES OLG. That makes up the Clean Tech system. How does it work? Right, so the graphs, what we're looking at here, there's basically two lines. There's the red line, which basically represents standard dispersed dyeing around the world, and then the green line is representing the use of the Clean Tech system. So what I'll say for starters, you'll still carry on with the same setting your pH of your bath, exactly the same, or selecting a pH buffer system. You'll put in the Clean Tech chemicals instead of the current incumbent dispersing and leveling agent systems. You'll put in your dye stuffs. The big difference then is you will then raise the temperature of the dye bath at 4 to 5 degrees, depending on the capacity your steam boilers can deliver. where the old traditional system was to go up at 1 to 1.5 degrees a minute. The reason, we'll go into another slide, but the reason is the old system, the rate of rise very much controlled the diacetyls entering into the polyester. With our system, the two main chemicals, the DIS and the LEV, control old like in the box system, the dye stuffs onto the polyester is perfect for opening. And then it controls the dye stuffs going nice and deep into the fabric. These two lines represent the initial big saving, that you're saving actual time in the dye bath stage. The next big saving comes is because the Clean Tech system is ensuring all the dye stuffs go on at the same time and they enter deeply into the polyester and they're locked. The need for a separate severe alkali reduction clear is vastly reduced. That means we can actually put the alkali reducing system in the dye bath as it cools back. The great advantage here is you are cutting out a complete water bath, a complete raising temperature to typically 80 degrees, and the time it takes to undertake that part of the process. In both cases, you always have to finish with a acid rinse, hence neutralizing the alkali and making sure that the fabric is pH neutral. Okay, so a bit more detail. Right, so polyester swells with temperature. It goes through its glass transition temperature, which is normally around 85 degrees. At 130 to 135 degrees, the capacity of the fiber to absorb dye stuff achieves a maximum, i.e. the fiber is fully open to accept the dye stuff molecules. With normal dyeing, with traditional dispersing and leavening agents, the dye stuff start to adhere to the fabric about 70 degrees. With heating, dye stuffs move to the fiber with increased speed depending on the temperature rise, and also blue, yellow, red dye stuffs will start going in at different times. To avoid issues like unleavenness, dye jets typically heat up really slowly, as I've mentioned, 1 to 1.5 degrees. So dyeing with the HeiQ Clean Tech system, the auxiliaries put the dye stuff in a thermal responsive box. That means they hold it. They're holding it close at lower temperatures and prevent it striking too early. So we're holding until the polyester is perfect to accept the dye stuffs. The dye stuffs are gradually released into the box at temperatures above 110 and evenly distributed in the dye bath and onto the fiber and can migrate onto the fiber. Okay, so that's basically covering the system. We're just going to cover polyester trials we've done previously. Before the pandemic, I actually did an awful lot of trials in Turkey and China, and more recently after the pandemic, we've also done some very successful products in Portugal as well. And then what we're showing here is basically that with using the Clean Tech system, we managed to reduce the dyeing time from 1 hour and 50 minutes to 2 hours and 36 minutes, a reduction of 31%. And the two columns in green and reddy pink sort of shows the areas of the process where we made those time savings. Again, thanks to the Clean Tech system, water consumption was reduced from 2,700 litres to 1,800 litres. So you're saving 9 litres of water are saved per kilo of fabric. Yearly water savings are 3.4 million litres of water per jet. And as Keith was saying, we're talking vast amounts, reducing by 33%. And again, we have just got some guides on what costs can be saved by using in water and energy by using the Clean Tech system. Okay, so just to cover again the energy and CO2 savings, steam, thanks to the time savings, total usage of steam on an oil capacity heater was reduced from 255 square meters to 101 square meters, reduced by 60%. Electricity produced by coal was reduced from 96 kilowatts to 66 kilowatts, which is a reduction of 31%. CO emission for steam and electric was reduced by 76 kilos. For annual production of a die-jet, this equates to 2,700 tons of CO saved per die-jet. Savings of $12,150 per year per die-jet on a car, which can be carbon offset on a carbon offset. So I think it's got two advantages in that it's controlling the dye stuffs, it's providing level dyeing, reducing time. It's a nice green story, but also it can increase capacity. Okay, so industrial production in a mill using this system, you can look at savings of 31% less dye time, 33% less water usage, up to 60% less steam, 31% less electricity, reduction of total cost to dye 1 kilo of polyester, including dye stuff, it's 5%, and excluding dye stuff, so your total energy and water and auxiliary usage equals 25%. Thanks to a 31% less dye time, each dye house can increase by 1/3 free capacity, which excites dye houses. By assuming a profit of 0.5 euro per kilo of dye fabric, the mill can potentially gain addition on top of the savings from each process. Basically, what we're saying is you're saving on each process, but also you can actually improve the mill capacity in the dyeing area by 1/3, which can equal to 60,000 euros more profit per year for each die-jet machine. That's basically hopefully covering the technical aspects how the die-fast system works. For the remainder of the presentation, I'm going to hand over to Keith. All yours, Keith.
All right, thank you so much, Paul. So next slide, please. So say you elect to adopt this system, how can you promote it to your end-use consumer? And so if you or your contracts choose to adopt the HeiQ Clean Tech system, here is a list of the marketing tools that HeiQ offers, which you can use to educate your retailers and your end-use consumers. Next slide, please. So just as a recap for the sustainability aspects of the HeiQ Clean Tech, next slide, you're going to save 30% of your water and energy uses on an annual basis. You're going to reduce the CO2 emissions by 30% during the dyeing process, and you're going to save about 35% of the dyeing time, so you'll be able to run an extra load of dyeing per shift or per machine. And this system, the HeiQ Clean Tech system, is Okotex suited, it's Blue Sign approved, and I had to look up what ZDHC is, but that is zero discharge of hazardous chemicals. And these products are currently available in the United States and in Latin America. Okay, Raquel.
Okay, everybody, welcome back. We've reached the end of the presentations. Paul, Dan, Keith, please turn on your video and mics. We're now getting to the questions asked. Paul, you can stop the presentation. Okay. Now I see we already have 5 questions. Now to repeat to everybody who maybe hasn't heard it, if you want to ask a question now, no matter how detailed actually, I mean, with over 100 years of experience in this industry, you will have an answer. So if you want to ask a question, please use the Q&A button to ask your question. Now to start up with the first question. Okay, I think this question is very technical, goes to Paul. Is there a color limitation? For example, very dark colors?
No, not at all. We're using this system on blacks and navies. We're using it on mid shades, and we're also using it on light beiges and calicos. So it covers the full shade spectrum.
Okay. The next question is it this system also workable for polyester or spandex?
Yes, you can use it on blends. I would say as long as it's polyester rich, you can use this system. But I would say that most people using this system, it's actually in a polyester spandex system.
Okay. The next question, does it have blue sign approval?
Yes.
The answer to that is yes.
Yes, yes.
Okay. Next question. Maybe this is also for Paul. Besides a faster dyeing time, what else can we expect? Any difference in hand feel or color retention?
And feel, no, it has no effect on the hand feel or the drape of the polyester. Color retention, we tend to find that you got better exhaustion, so you get better reproducibility. The color retention improvement leads to 2 things. It leads to a better fastness, and it also leads to you being able to add the alkali reducing agents in the dye bath, which allows you totally to cut out the second dye bath. So yeah, the better entrampment of the polyester leads to better color retention.
Okay, thank you. Next question, another technical question for Paul. What about other dye bath chemicals such as pH control, lubricant, chelate, SCQ, etc.?
Remains exactly the same. The choice of pH, if you want to set it on the acid side at the beginning, or if you want a buffer system to lower the pH and maintain the pH, remains exactly the same. And if you have any lubricant or anti-wrinkle system in there, or even some non-ionic softener, they all remain exactly the same.
Okay. The next question. What's the cost comparison to a standard system?
For the chemicals, I would say the chemicals should be on par. To actually work out the savings, you should be looking at basically a 30 to 35% reduction. To gain a full and accurate calculation, you need to run a dye in their system, because ultimately we've got to understand their steam capacity, their current rate of rises, their current rate of cooling. So I would say that they would expect a 30 to 35% reduction in costs, even accounting for the cost of the chemicals. But a true calculation can only be achieved in actual dye house after you've studied all their parameters.
Okay, thank you very much. The next question again is for you, Paul. Is it compatible with other dye classes possibly present in the same dye cycle?
It's compatible with all dye classes, all 4 dye classes of polyester and grey color dye classes, what you see in automotive industry. If they are talking about adding some kind of acid dyes or something for dyeing nylon, the answer is it will not have any impact on those dye classes.
Okay. And the next question, still technical. So Paul, do you have a recommendation for dyes with high molecules such as turquoise?
Turquoises, We always sort of run at 0.7 grams per litre. Yes, turquoise is always a challenge. So I will go 0.7 of both the LEV and the DIS. And then if you're dyeing turquoises, I think there's also advantage of putting a little bit of the OLI and mega per kilo in there. But yeah.
Okay.
That's going straight for the most difficult shade.
For sure.
Okay. Next question. Can it be used with polyester cotton? So a blend polyester cotton?
Yes, it can. Yeah, as long as the polyester is 50%, yeah, no problems at all. You're dyeing your polyester in exactly the same manner. You're dyeing your cotton in exactly the same manner. So yes, it can be used on CVC fabrics.
Okay. And the next one, do you have illustrations of the rate of dye and migration versus conventional systems?
Yes, we do have a nice picture in one of the PowerPoints, what does show the buildup of dye stuffs, which can be shared with people.
Okay, and we have the name of the one who asked, so we could send him the illustration later per email if interested. Okay.
Okay.
Okay. Next question. Again, technical. How does it work in the presence of high elastane content? Mostly interested in the levelness.
I presume if somebody's got 20 to 30% elastane, the answer is it's still exactly the same. The oil and the elastane does not affect it, and you'll still, if you want to put a little bit of acetate 1,1,2,1 dyes in there to stain the elastane, you'll still do that exactly the same. But the answer is it's not, it doesn't create any difference. You'll still add the same amount of the free chemicals and run the parameters exactly the same.
Okay. And next question, still technical. Do you have any suggestions to cationic polyester?
No, we don't. Sorry. That is a completely different dyeing system. As we've said several times, this is totally dispersed dye stuffs.
Okay. And the next question, how long does it take to implement in a, in a mill that has with the dye? Yeah. Yeah, in the present system, if you do standard dyeing, how long does it take to implement, I think?
No, normally when we go along to mill, we normally select something like a 50 kilo machine and do a dyeing in there. We'll then do one in a bigger 150 jet. I think most dyers like to see a dyeing on a light shade like a calico. They like to see it on a turquoise, and they like to see it on the black. So they're then covering like the three evils of dyeing polyester. And but I would say typically 4 to 6 weeks, because ultimately the dyers will want to do small dyeing, big dyeing over shaded ranges. They'll want to do the color fastness checks. They'll want to do the delta E's on different parts of the fabric. But I would say it could be safely implemented in a time period of 6 weeks.
6 weeks, okay. Okay, the next question. Is any mill currently using this system for bulk processing?
We've got mills in Portugal, mills in Turkey, mills in China, which are currently using this system for bulk production.
Okay, next question. Could it have any value in continuous dyeing, for example, running faster?
We've never studied it on continuous dyeing.
But that's a good question.
It's a good question. I mean, it could be studied.
Yes,
I'm not saying
excellent.
no, I'm saying it hasn't studied. Everything we've done has been batch dyeing.
Okay. Well,
it depends if they want to incorporate dyeing at a higher temperature. It's a good question, and studies could be made to keep things above 90 and try to save water. Yeah, interesting.
Yes. Okay, we have the name of the person who asked, so maybe we can get in contact afterwards. Next question. What are the typical concentrations of clean tech chemicals?
For dark shades, navies and blacks were normally running at 0.5 grams per litre. For difficult shades like turquoise, we'll run at 0.7, and for light shades, we'll run at 0.7 grams per litre. So basically, if it's a difficult dye stuff monocool, or if it's not saturated, we can reduce it. We have to increase it. With dark shades where it's totally saturated, we can reduce it. And what I would say is, it isn't one of the, you've got to select the right amount. If you don't have enough in there, there's always a danger of being slightly unlevel, but at the same time, as any level systems, there's an optimal level, and after that you can start resistance. So ranging between 0.5 to 0.8, depending on your dye stuffs, depending on your steam capacity and a few other things, but that's normal.
That has to be figured out at every mill, Rahel. Basically, that's why we do the trials, is to figure out exactly where we need to be.
I think that leads to the next questions. Who shall I reach out to if I want to proceed with a trial with my suppliers? And the suppliers are located in China, Vietnam, and India. And what's the minimum order quantity was done, including in this question?
We tend to deliver in 100 kilo drums. Keith changed that to something like 44 pounds or something. It's in America. Right, so we've got his own office and warehouses in China, so you should reach out to us. We can link to the team there. We've got his own office in Sri Lanka. What will reach out to our distributor in India. Vietnam, we have got a distributor in Vietnam, and also our China team helps for the Chinese control mills, and the Taiwan team helps for the Vietnam mills. Vietnam, you basically got to select depending on the owners and the origins of the mills, but certainly we've got support in all those areas.
If this is a US-based mill, Rahel, they can reach out to me and I can put them in touch with the correct people in those areas.
Yeah, I think it's a brand with mills in Asia. Yeah,
I think so.
We can link them to the relevant people.
Yes.
Yeah. Okay. Next question: is your system suitable also for alkaline dyeing of polyester?
No, it's about a typical acid control dyeing system. I must admit, that's a new one.
That's a good one, because that's for automotive a lot.
Okay. And the next question: is it possible to combine HeiQ Clean Tech with functional treatments, for example, moisture control chemicals?
Yes, I did mention that. A lot of people put in moisture control, non-ionic softeners, hydrophilic softeners in the dye bath, and the answer is yes, they can still be applied in exactly the same manner.
Okay, then there's a question about the cooling process, if it's the same or faster with
the cooling process is exactly the same. It always has to be with polyester to make sure you nicely go through your TMTG points again, and you're avoiding any disruption to the polyester or crease into polyester. So cooling remains exactly the same.
Okay. Next question: does it work for low energy, medium energy, and high energy disperse dyes? Are there any limitations?
No, all the energy dye stuffs and the monocle sizes, it works the same on all of them. It holds them in the thermo lock until the polyester is ready to accept.
Okay, next questions. Can we use these trials, or can we trial on fibers instead of fabrics?
Yes, we have successfully dyed loose stock, and in Turkey, that was also done in Turkey, so it can be used on loose stock, staple fibers, and yarn dyeing systems as well.
Okay, next question: how about the fabric appearance after dyeing? Is it the same appearance compared to slower dyeing?
The fabric appearance remains exactly the same. It has no effect on the appearance.
Next question: what is the percentage of depletion of the dye compared to standard dyeing?
Depletion of the dye. We
How much,
we-
how
we're-
much dye is, how much dye are you utilizing?
the aim is actually we find it's very high, between 97 and 99%. That's another reason why we get good fastness, because and we also get good reproducibility from batch to batch, because you're basically exhausting a high amount of the dye stuff into the fabric.
Okay. Next question. Do you also test your system on dyeing high tenacity fibers? Would it work?
The answer is yes, it would. Yes.
It would. Okay. Do you have an example? Actually, I'm curious myself. Anybody used it for that?
I would say at HeiQ in Turkey, we've sort of used high tenacity on some industrial curtains and things. So yeah, at HeiQ down in the south of Turkey, we've done some dyeing on high tenacity yarns and fabrics.
Okay. Then the next question is, are there samples available of polyester samples dyed with HeiQ Clean Tech?
Fabric samples?
Yes.
Not particularly.
I don't have any.
Okay. I guess we could do it at their mill and then we have their samples right there.
We could, yeah.
That's the idea. Yeah, the idea.
Yeah. Next question. Is this a new product recently launched?
No, we actually initially launched it. I think it was back in 2019. So 2019, we was doing quite a lot of work in Turkey and China. I was in China right up to December running trials, and we got it installed in some mills. And then, as everybody knows, Mr. COVID came along and stopped play a bit, as it did with a lot of things. But yeah, I would say we was definitely running it in 2019, and then mills what we incorporated have been running it for the last 2 years.
Okay, next question. Is the amount of reductive cleaning agent and caustic soda the same compared to the standard process?
That's a good question. Again, that's a little bit in-house. The big advantage is you can add the alkalis in the cooling dye bath, and B, studies to be made, but there is an opportunity to reduce the amount of alkali by 20-25%. But again, that needs in-house studies. Initially, you would apply the same amount, but in the cooling dye bath, if that's totally successful, yes, you can look at reducing the alkalis back 20-25%. But in-house studies would be required.
Okay. Next question. Does the leveling agent contain benzyl benzoate?
It's sulfonated. No, it's sulfonated. Sulfonated resin. No, it doesn't.
And does it work on all types of dispersed dye stuffs?
Yes, it does. Yeah. Regardless of energy level or molecule size, the answer is yes.
Okay. So we've actually reached the end of the questions. If anybody still wants to ask a question, now's your chance. Otherwise, we will send out the viewing link to the recording to everybody who signed up, so you can watch again. Or you can send an email. You have my email address. I can forward to the person in charge with additional questions. Now I see there were a lot of questions actually. I see there are no additional questions. So yeah, let's stop 5 minutes early. Thank you very much for joining. And HeiQ is holding textile related webinars throughout the year. Keep your eyes open and join us in our next webinar. Thank you very much and bye-bye.
Thank you, everybody.
Thank you, Ella.
Bye.
Thank you, everybody. Bye-bye. Thank you.
Bye.